going to learn that in this section. We're going to start with what it takes for two matrices to be equal. Two matrices are equal if they have the following two things in common. They have the same size, so the matrices have to be the same size, and all of their corresponding entries are equal. What do I mean by corresponding entries? Well, I'll talk about that when we look at some examples. When I think of corresponding entries, I think of entries that are in the same positions in the matrix. So look at example set 1, number 1. It says, find the values of the variables for which each statement is true. And notice that this is the first time we've seen a matrix set equal to another matrix. I think that's the first time we've seen that, right? So I have a matrix equal to a matrix. So when you have a matrix equal to a matrix, you have to make sure that these matrices are the same size. Are they?
Yes.
What are the sizes of these matrices? This one, yeah, they're both square matrices, right? This one's a 2 by 2, and so is this one. They have to be the same size in order for them to be equal to each other. If you have two matrices equal to each other that are not the same size, it's a contradiction. They have to be the same size. That's one of the criteria. Now, once they're the same size, in this case they are the same size, right? Then we have to make sure that all of their corresponding entries are equal. Now, here comes the fun part. Corresponding entries. Corresponding entries are entries that are in the same positions in both matrices. Now, here you've got colors. You got colors, perfect opportunity. See the W? W and 9 are corresponding entries in both matrices. Why are the W and the 9 referred to as corresponding entries?
Because they're in the same position.
They are in the same positions. They're both in the upper left-hand corner. So they're in the same spots, right? The same position. I like to use the word positions, but they're in the same positions in both matrices. So we call the W and the 9 corresponding entries. Well, guess what? Those corresponding entries must be equal. So since the corresponding entries must be equal, guess what W is equal to? 9. Well, you found the value of W. Now, can you get the values of the other ones? Let's see. Well, X must correspond to 17. So what's X equal to? Yeah. You just found the value of X. Oh.
Well, but you're still not helping me understand what we're doing here. That's what it is.
It's asking you to find the values of the variables. In this case, we have W, X, Y, and Z that we need to figure out. So we have to find the value of W that makes this statement true. Well,
okay.
Since W and 9 are in the same positions,
so they match up.
They match up, so then W must equal 9. Remember what the notes say.
Right.
Corresponding entries are equal.
Yes.
Ah, there you go.
When you understand that W is not 9, I was looking for 9 equals 9. That's what I was looking for.
Oh, okay. Well, in this case, since we have a variable there, though, we're matching them up, though. We are matching them up.
Okay.
So W and 9 match up. They're in the same spots. They must be equal.
Okay.
X is 17. Can you tell me what Y is?
Y is 8.
Oh, you're getting there. You got it. You got it.
You
And
can't put 8 equals Y, you have to put Y equals 8?
doesn't matter. Either way. Which one do you like better?
Well, it doesn't matter because they're both equal.
8 equal Y, Y equal 8. It
Well, yeah,
sounds the
because it
same to
comes
me.
in that,
What's that? Are you a lefty or a righty? You like to have Y starting on the left?
well, because we started this way, Y equals 9, X equals 17, so start 8, Y, make it equal.
You could, just for consistency. But the point is, at the end of the day, they're equal to each other, so you have found Y. Y is 8. How about Z? Z is negative.
20.
Do not get this wrong. This is not where you want. Then, if you do, then all of a sudden this becomes a difficult section. Yes. Okay. I'm trying to make this easy for you. So far, so good. So when students do this problem, guys, they tell me, "Is that it?" And I tell them, "Yes, that's
No.
it." For this
No.
one. For this one, it is.
Okay, for this
For
one.
this problem, it is, right? I didn't finish my sentence, did I? I spoke too soon. Okay.
Yeah.
All right. I got to be careful what I say here.
That's deceptive.
But what do you think? I know, right? What do you think so far, though? Isn't that nice?
Yes.
Oh man,
That's the easiest way to find X.
sure is. Look at those colors. It helps to show the corresponding entries, right? So all of those corresponding entries are equal. So it helps you to find a value of a variable. If I have a matrix equal to a matrix and I'm trying to figure out the value of the variables, we can use this strategy to help us. Take a look at the next one. Let's do one more together, and then maybe this one you can check it on Blackboard. But let's do number 2 together. Now, look very carefully at this, you see that, remember, if I look at this matrix, x plus 2, y minus 6, z minus 3, w plus 5, you notice that there's a space between the x plus 2 and the y minus 6, so that indicates that this right here is one column, okay? So because columns are separated by space, right? There's not enough space here, these are considered to be together, because even though they're different terms, but, so this is.
So x minus 2 equals negative 2?
You're onto something, but the point is, this is a 2 by 2 matrix here.
So that meets that first requirement.
Yeah, because they have to be the same size, and in this case they are. They're both 2 by 2 matrices again. And then, yeah, so what does x plus 2 correspond to?
Negative 2.
Negative 2, very good. Can you tell me what y minus 6 corresponds to?
Negative
Not negative 8.
8.
But you meant 8, right? Hi, Eunice, be careful. Ten cuidado. How about z minus 3? 0. And last one, w plus 5? 3. Okay, so set up those equations. See, I have to find the values of the variables for which each statement is true. So if x plus 2 is equal to negative 2, set up that equation. I want to solve that for x, right?
Oh, we're gonna do that.
Yeah. See, x is not isolated this time, like it was in the previous problem. In the previous problem, it was nice because the variable was already isolated, but if it's not, then just do a little algebraic step to get x by itself. It looks like I have to subtract 2 on both sides. So you make that happen, and x equals negative 4, right? Okay, and then just do that for the rest of them. I think I have room to fit these, barely, right? Let's see. Put like a little, should I put like a little separator? So y minus 6 is equal to 8. Add 6 to both sides, so what's y equal to?
Y equals 14.
Y is equal to 14. Nicely done. And then z minus 3 equals 0. Z is equal to 3. And one more. Well, w plus 5 equals 3.
So then it would be w equals negative 2?
Yep, very good. W equals negative 2. You have found the values of the variables. That's it? That's it? I think that's it. For this part. I said, for this part. Yeah, I haven't finished the section yet. I'll let you know when I finish the section. Then maybe we should. Then you can ask that question. How's that sound?
So we don't need to do number 3, right?
No, we don't. I'm going to skip that one, but you can check it on Blackboard. It's very, very similar. Try to find the values of A, B, C, and D. Now we're gonna get into adding and subtracting matrices. Well, first of all, to add or subtract two matrices, they have to be the same size. That is a requirement. So just like two matrices equal to each other have to be the same size, two matrices being added or subtracted must be the same size. So there's some restriction there, isn't there, right? You can't just add any old two matrices you want. They have to be the same size. Now, if they are the same size, then to add or subtract two matrices, all you have to do, guys, notice I put here simply. Simply, sounds simple, right? Simply add or subtract the corresponding entries. And we'll save this one for later. We're going to also learn how to multiply a matrix by a number or a constant. In mathematics, we call a constant a number. We've seen that already. So to multiply a matrix by a constant or a number, we just multiply each entry in the matrix by that number or by that value. I'll show you how to do that. But here's what we're going to do. If you look at example set 2, before we get into example set 2, I just want you to know, I want you to be aware of something. That sometimes in mathematics we have to label, things have to be labeled, right? And when we're working with more than one matrix and we're going to do some operations on them, sometimes we want, or it's convenient for us to label a matrix. And the way we label matrices, we use capital letters starting with capital A. So capital A is this matrix.
So it's like, that's assigned, it's assigned
Yeah.
identity.
Right.
Okay.
You can think of it like that. It's kind of like you're giving that matrix a label, a name. So I'm
It's
going
like
to call.
the room that all those numbers are in.
Yeah, exactly. So yeah, it's a way of identifying the matrix, because if I didn't put those,
And you were
then-
trying to explain to me what you needed me to
and
do.
yeah, exactly. It's kind of like giving you So when I tell you to add A plus B,
We already know
No,
what it is.
you know what A is, you know what B is,
We know
right?
that we're gonna add group A.
It's like an
to B.
identifier.
Yeah, that makes sense.
You think of it as like an identifier. So this matrix 1, negative 1, 2, negative 1, I'm going to call this matrix A. And the matrix 2, negative 1, negative 1, 8, I'm going to call that matrix B. So they've been identified by capital letters. And if most of the time for matrices, the capital letters that are used are A, B, and depending on how many matrices you're working with, sometimes they use capital C and capital D. But hopefully you won't have to go more than that. I don't think they use more than those, but that's the majority of, that's, A and B are the most common capital letters used for matrices. They start with those, but, so look at example set 2. It says, if possible, find, and I know that there's several parts to this problem, so we're gonna just do one part at a time. So in part A, they want me to find A plus B. So they want me to take matrix A and add it to matrix B. So let's do that. So part A would look like this. If I want to find matrix A plus matrix B, it would be this. Make the replacement.
1 plus 2.
Okay, you're onto something. 1, negative 1, 2, negative 1, plus 2. Notice how I'm making the replacements of the matrix? So in other words, I'm replacing capital A with its matrix,
Right.
plus replacing capital B with its matrix.
Right.
And very good. Someone said 1 plus 2. So here's what you do. It says to add two matrices. Maybe I should have, you know what, before we add them, I was supposed to confirm if they're the same size. Are they?
Yes,
Oh,
we
they're
are.
both 2 by 2, so we're good there, right? Which means, yes, we can add them because they're the same size. As long as they're the same number of rows, as long as their rows match, and then whatever their columns are also match. But in this case, they're both 2 by 2. And also, since they're the same size, we now can add the corresponding entries. Now, when you add the corresponding entries, the result of that goes in the same spot or same position. So these corresponding entries that are in the upper left-hand corner, when I add them together, the result's going to go in the upper left-hand corner. So,
Okay, can I ask a math question?
sure.
Is the plus a constant, so on negative 1 and negative 1 respectively, is that negative 1 plus negative 1?
Yes.
Okay,
Yeah. So think of it as like you're adding two negatives.
yeah.
Yeah, that's how you want it. That's how you can think of it. That's right. Very good. Very good. I don't think I'm going to have room to squeeze all that. I wanted to actually show the numbers being added just for the first time, since I'm showing it for the first time. 1 plus 2, and then space, negative 1 plus negative 1. Yeah. It's too small. Hold on. I think I can fit it though, but this is not ergonomically designed. That's fine. There we go. Barely, right? And then down now I'll color. Don't worry, I'm going to color code it later. But 2 plus negative 1, and then negative 1 plus 8. So color code time. Check it out. Ready for this? Make sure you know where everything's going, right?
Do we need to write it like that?
No, you don't. I'm just doing it for the first time.
Okay.
I'm not gonna, like, for the next ones we do, I won't show it. I'm just gonna
Okay.
put the answer. But I just wanted to
So
do
we
it
can see the
just so I can say that I showed it one time.
correlation.
These do need to be cleaned up, but I just want to show you what I did. So you see that if you see what I'm doing, you notice that I'm just adding the corresponding entries. So it feels like you're doing 4 separate additions here. And then you just clean up each one, and then that resulting matrix is the sum of A and B. So my answer would be 3, negative 2, 1, 7. There it is. And the answer is the matrix. Look what I boxed. Your answer is not just a single number, it's the entire 2 by 2 matrix with those numbers in them. So your answer is that entire matrix, not just a single number. If I'm looking for a determinant, remember when we did determinants back in the previous section? A determinant is a number. But when I'm looking for the sum of 2 matrices, notice my final answer is a matrix. So be careful with that. Yeah. Sir, what if the matrices were different sizes and they told me to add them? Well, if the matrices are different sizes, if the sizes are not the same and they tell you to add them together, the answer would just be they cannot be added. You would not be able to even carry out the calculation at all. So they have to be the same size before you can even begin to think of adding them together. You know what I mean? You can't add them if they're not the same size. That's bottom line right there. Okay? Any question with addition? What if I were to tell you that subtraction is very similar? The only difference is instead of putting pluses here, you're gonna put minuses. So subtraction is in the same boat, just different operations. So look at part B. What if I wanted to, same two matrices, what if I wanted to find A minus B? Well, that would be, let me show my work. Maybe this, well, you know what, no, I'll tell you what, since it's the first one, I'll go a little, I'll kind of keep it slow, but, so it would be 1, 2, -1, -1, minus 2, -1, -1, 8. Now, be careful that this is what it would look like. 1 minus 2, -1 minus -1, right? Then 2 minus -1, and then -1 minus 8. Make sure you're looking at the correct corresponding entries. What some students will do is they'll put their fingers on the numbers that they know are the corresponding entries and then just make sure they subtract those. But the biggest mistake students might make on these, where it could become a difficult problem, is when they accidentally subtract entries that are not corresponding. Be careful. You want to make sure they're corresponding, the ones that get subtracted in each corner. In this case, or each position. And then just clean these up. So, oops. Oh boy. Want me to use, yeah, you want me to use the highlighter to finish this problem? That would be interesting, right? Yeah, that would be some big font, right? I don't think that would be too good. -1. Be careful with the signs here. I would, subtracting a negative becomes addition, so if you face with this, it just becomes plus. So that becomes -1 plus 1, which is 0. 2 plus 1 is 3, and -1 minus 8 is -9. There it is. And just enclose it in square brackets, and that is your answer. Yeah, make sure you put your matrix is supposed to be enclosed in square brackets, just like these are. So when you find the sum or difference of two matrices of the same size, the resulting matrix will also be that size, and you just want to make sure there's square brackets around it, because that's the way a matrix is written. Any question with the difference? So kind of similar to addition, just the difference operation, right? So you just subtract corresponding entries, that's all. Now, take a look at part C. What if I asked you to find something like this? 3A. 3A, what does that mean, right? Well, that goes back to this part in the notes. To multiply a matrix by a constant or a number, you multiply each entry in the matrix by that value. So if they give you something like 3A, you're multiplying a matrix by a number. And the way you know that is because you have the number right in front of the matrix, so that's an implied multiplication. So you're going to multiply 3 times the matrix A. So the way this works is like this. When you see this, you're going to be like, really? That's it? 3 times matrix A would be this. 3 times, replace the matrix. All you have to do, guys, is multiply, make sure that 3 gets multiplied into all of the entries in here. So it would be 3 times 1. I'll show my work the first time, right? 3 times -1, 3 times 2, and 3 times, oops, and 3 times the other -1 that was down there. And clean this up. So this would be 3, -3, 6, -3. And that is my answer.
For part A.
For part C.
Oh, for part C.
They asked me to find 3 times matrix A, yeah. Any question with that one? So you see what that involves. So if I have a number multiplied by a matrix, you just multiply each entry in that matrix by the number. That's what you do, okay? And then, if you can do this last one, then you really shouldn't have any problem doing any of the others, but let's do one more together. Let's see. Yeah, example set 3, you can check that one on Blackboard. But maybe we could do number 2, we could do number 2 together also after we finish this, okay?
we
So-
gonna do D?
Yes, we're gonna do D though, right? Yeah, let's do D. Any question with C though? C is not too bad, right? And then D, look at part D. 3 times matrix A minus 2 times matrix B. Wow. So now we have a combination of multiplying a matrix by a number and doing either an addition or a subtraction. In this case, it's a subtraction. But how do I handle a mixture, right? What if I have more than one thing I have to take care of? Well, what I would do is start with multiplying the matrices by the numbers first. So if I want to find 3 times matrix A minus 2 times matrix B, I would first write it like this. 3 times 1, negative 1, 2, negative 1, which we actually did earlier, but I'm going to show it again. Minus 2 times 2, negative 1, negative 1, 8. That's how I would set it up in the beginning. So so what do I do in the beginning? I replace capital A and capital B with the matrices respectively, since they were labeled that way. And then what I would do is go ahead and multiply the 3 into this matrix. And for this matrix, for this one, I would just take only the 2, leave the minus sign alone. We're going to treat it as a subtraction later. That's my recommendation to you.
So they might use a negative 2 times the 2 and then negative 2 times
But,
negative 1.
yeah, and I've even in the past, I've even tried explaining it that way, but I'm afraid, I feel like it might confuse the students, unfortunately.
Yeah, so it'd just be the minus.
It's better to just treat it, it's better to respect the original operation that's there. So I'm gonna treat this as a subtraction later. Since we've already learned how to subtract, I'm just gonna take only the 2 and distribute it. So let me highlight that, just letting you know that I'm only gonna take the 2 and multiply it into each of the corresponding entries, but not the minus. So just be alert that that's what I'm going to do. So we're going to have this now: 3, negative 3, 6, negative 3, minus, just multiply the 2 in there only. That would be 4, negative 2, negative 2, 16. Question? What do you think? I think overall it's easier that way, because this way you're respecting the original sign that's there, because I'm afraid that if I do something to change that, it might throw you guys off, or maybe some may understand it, but I want to be consistent and just say, well, because this is a little easier because students know that, well, that was our sign, and then we know how to subtract 2 matrices. We've already done that, so why not? So what's wrong with keeping it a subtraction? That's what we want to do. It is a subtraction. So then subtract corresponding entries. Let's do a little more practice with this. Let's see. Okay, let's see if we can do it this time without showing the actual subtractions. Can we just do this in our head if we're very careful? Put your finger, if you really? Okay, I thought you were being serious with me.
No, well, I can't.
Okay, well, if it helps, guys, if you just want to get the results without showing 3 minus 4, then put your fingers on the corresponding entries when you do this. So that way you won't accidentally pick the wrong numbers or something. So I know I need to do 3 minus 4. That's going to go in the upper left-hand corner. 3 minus 4 is negative 1. Then
3 minus negative 2.
yes,
Negative
3 minus negative 2. Watch your signs there. Minus and negative becomes
Positive.
plus. So negative 3 plus 2.
That would be negative 1.
Negative 1. I have the result here, so I know I'm getting it right. But be careful.
Otherwise.
Be careful. I know, right? Be careful. If I didn't have it, I'd be like, okay, guys, did I do it right? Help me out here. Okay, 6 minus negative 2. Here we have a subtraction of negative 2 again, so that's like saying 6 plus 2, which is 8. So yes, you can do this in your head, but just be very careful and make sure. If it helps, put your fingers on the entries that you know you're going to subtract. That way you're not accidentally looking at the wrong ones. Negative 3 minus 16. Negative, be careful, you're close. Negative 19. There you go. Be careful. There it is. This is your answer for 3 times matrix A minus 2 times matrix B. So we're learning how to perform operations with matrices. Now, all we're doing though is addition, subtraction, and multiplying by a number. That's all we're going to cover. The book covers a little bit more, but we just can't get into that kind of. We just can't get that deep into this section.
It's not going to give us homework on that stuff, is it?
No. Well, I mean, the homework is going to be based on what we're doing here.
Okay.
So So I made sure that the homework I assigned was relating to what we were gonna do in class. It should. Let me know if it doesn't though, but it should. It should. Because I picked the problem specifically.
Okay.
That should work. Let's do number 2. And after number 2, I'm gonna kind of let go of the training wheels and let Blackboard take over to fill in the rest of this stuff for you. But hopefully you're gonna get you'll get the gist of it after number 2. I'm sure. Let's do problem number 2. The same 4 parts, A, B, C, D, but with these 2 matrices. On number 2, we have matrix A is 6, -1, 2, 4, -3, 5. Matrix B is 1, 4, -1, 5, 1, 10. And notice the size of these matrices. How many rows?
They're equal, because there's 3.
So that it's a 3 by 2, right? They're both 3 by 2 matrices, so they're the same size, right? As long as they're the same size, they have the same number of rows, same number of columns. So therefore, because they're the same size, I have the ability to perform these operations on them, right? I have the privilege, I have the right. If they were different sizes, I wouldn't even begin to add or subtract these matrices. I would just immediately say, cannot do it, right? So always inspect their sizes first, just to make sure that they're the same. If they're not the same, you're done. You just say, cannot do it. But you know, if you're adding the 2 matrices together or subtracting them, you simply cannot do it if they're different sizes. So remember that. Let's find A plus B. So this one, just an extension of what we've already done. So notice what A represents this time though. It's 6, -1, 2, 4, -3, 5. Right? Plus 1, 4, -1, 5, 1, 10. So notice we are still adding corresponding entries together, and you can see where the corresponding entries are, I'm sure. So it's pretty much in the same boat as the previous problem, but you just got to see where your corresponding entries are. And yeah, I'm running out of color, so that's okay. So you can see that that's pretty much how it works, right? Where there's a will, there's a way, right? Okay. So add corresponding entries together. 6 plus 1 is 7. -1 plus 4 is 3. 2 plus -1 is 1. 4 plus 5 is 9. -3 plus 1 is -2. And 5 plus 10 is 15. So it kind of feels like you did 6 separate additions, right? You did 6 separate additions, but at the end of the day, you get your matrix result. So that entire matrix is my answer for A plus B. Any question? Did it feel like you were doing 6 separate additions? No? Well, kind of. Well, when you think of it, like, since it's a 3 by 2, you have a total of 6 different numbers in here, 6 different numbers in here. So when you look at the corresponding entries, there's going to be 6 separate additions you have to do, right? Yeah, and so you just complete those 6 separate additions, clean them up, and you form the matrix, and you're done. Any question with A plus B? No? It's not too bad, right? How about A minus B? Well, similar, but all we're going to do now is just subtract instead of add. So for completion, let's show it. So A minus B is equal to so A minus B is equal to 6, -1, 2, 4, -3, 5, minus 1, 4, -1, 5, 1, 10. Watch your negatives, but go ahead and subtract corresponding entries. 6 minus 1 is 5. -1 minus 4 is -5. 2 minus -1 is the same thing as saying 2 plus 1, which is 3. 4 minus 5 is -1. So you see what I'm doing, right? -3 minus 1 is -4. If you don't see it, let me know. 5 minus 10 is -5. There it is. Okay? Any question on A minus B? More practice with that, right? And if I needed to do 3 times matrix A, that would just be, notice that if I'm just finding 3 times matrix A, I'm only working with this matrix because they don't tell me to do anything with B, with matrix B in this part, right? In part C, I'm just finding 3 times matrix A. So that would just be 3 times the matrix 6, negative 1, 2, 4, negative 3, 5. Multiply the 3 into each entry. Make sure each entry gets multiplied by 3. So you would get 18, negative 3, 6, 12, negative 9, and 15. Questions? There it is. That's the answer. Okay? Questions? Anybody? Everybody with me? Okay. All right. And let's see. And then the last one. This one, if you understand this one, then really then you really do get the gist of this section, if you know what I mean. You really do understand it if you're seeing it so far. And it's not too bad, right? But take a look at this one. Let's see if we can do 3 times matrix A minus 2 times matrix B. So that would be what? 3 times the matrix 6, negative 1, 2, 4, negative 3, 5, minus 2 times the matrix 1, 4, negative 1, 5, 1, 10. Now here's what I recommend you do. Take care of the constants first, but again, not ignoring, but just bringing down the minus. So only distribute just the 2. So we would have 18, negative 3, 6, 12, negative 9, 15. That was 3A, right? Minus, now just multiply only the 2 in here, just the 2 only. So it'd be 2, 8, negative 2, 10, 2, 20. Okay? And then subtract corresponding entries. 18 minus 2, 16, negative 3 minus 8, negative 11, 6 minus negative 2, that's 6 plus 2, which is 8. Then 12 minus 10, make sure your fingers are on the corresponding entries. Don't accidentally look at the wrong numbers. 12 minus 10, 2. Negative 9 minus 2, negative 11, and then last one, 15 minus 20, negative 5. Any question? There it is. This is the matrix 3A minus 2B. We found it. Okay, questions? Okay. And that's pretty much, so what you've been seeing is a lot of repetition, but it doesn't hurt to really let it sink in that that's what you do when you're trying to add or subtract matrices together. So just remember the capital A and the capital B represent those matrices. They've been labeled that way. You could say they're representing the matrix. Okay? And then the last one, I just put it all together, but this is the one you can check on Blackboard. This is the one I'd like you to try on your own, and you can check the answer on Blackboard. With those 2 matrices, matrix A is 1, 2, 2, 1. Matrix B is negative 3, negative 2, 4, 2. They want you to find A plus B, A minus B, and then on part C, they want you to find negative 4 times matrix A. And then try to find 2 times matrix A plus 6 times matrix B. I recommend you try to work them out on your own first, and then when you're finished with them, check the result on Blackboard and see if you get the same thing. Hopefully you will, and if you do, then you pat yourself on the back, because that means you did it properly, you followed it correctly, and you got the right numbers. And if you don't get the right numbers, no, well, or just if you don't get the right numbers, well then try to find out where you made the mistake, right? Obviously a mistake was made. You want to find out where it happened and try to correct it. But that takes care of 5.7, guys, and that's it for 5.7. So now I'm ready for the question. Ready? What was it?
Is that it?
Is that it? That's what I knew it, right? Isn't that true? Isn't that how you feel? You wish this would have been our first section in chapter 1, yes? This should have been the first section in chapter 1. This should have been 1.1 right here, or 1.3.
No, because then we would have gotten confident and we would have thought, oh, it's
That's
that
true.
bad,
That's
and
true.
They were pulled the carpet one.
Yeah, so maybe it was good, maybe it was a good thing to kind of pull out the carpet early on, huh? But you know, the point is the carpet's gotta get pulled out eventually, and might as well